Hello, everybody. Welcome to our lesson on trig ratios. So, trigonometry in geometry is the study of right triangles. That's why we start with the TRI. So, it's the study of right triangles. And in particular, it's the study of the ratio of the sides of right triangles. So, let's start with this opening problem, reviewing the 30, 60, 90 special right triangles. And then we're going to use that to define what a trig ratio is. All right, so remember that in a 30, 60, 90 right triangle, the short leg has a length of A. The longer leg is always square root of 3 times that, and then the hypotenuse is 2 times the short leg. So if you have a 1, you have a 1 radical 3 and a 2. Then a 2 radical 3 and a 4, 3 radical 3 and a 6. Now, these are all similar triangles. So they're similar because of angle-angle similarity. You could also use side, angle, side, I suppose, or side, side, side. But by angle, angle, right away, every right triangle with the same angles is always going to be similar. It will always be proportional. Now, that's really important because not only, for example, let's go from the small triangle to the big triangle. We know that's a 1-to-3 ratio, right? And so then 1-to-3, 2-to-6, right? Well, now let's look at the ratio of the short leg to the hypotenuse. 1-to-2 ratio. Short leg to hypotenuse. 3-to-6, which is a 1-to-2 ratio. Okay? That will always be a 1-to-2 ratio. Okay? So we're going to define that in just a second, but does that make sense? Not only is the ratio the same side to side, but a corresponding side to corresponding side, but the sides within the triangles are the same ratio. Well, those ratios are called the trigonometric ratios. Open to your vocab. We have tangent of theta equals opposite leg over adjacent leg. Sine of theta is the opposite leg to the hypotenuse ratio, and the cosine is adjacent leg to the hypotenuse ratio. All right, so what does that mean? So let's say we're looking at what we're going to call the tangent of 30 degrees. So for any right triangle with a 30-degree angle, if you look at the side opposite the 30-degree angle over the adjacent side, leg, not the hypotenuse, the adjacent leg, then that ratio will always be 1 to square root of 3, which we always rationalize our denominators, square root of 3 over 3. Okay? That ratio will always be the same, and you can look at a different triangle. 2 over 2 radical 3. Oh, that simplifies to the same thing. 1 over radical 3 over 3. Go ahead and type in your calculator the square root of 3 over 3. And you get approximately 0.577. Okay, now go to mode. We only have to do this once unless you're switching calculators. Go to mode degree. So you're in degree mode. Now I want you to type tan, press the tan button, and then 30. Enter. Look what you get, 0.577-ish. Okay, so the calculator knows that for every right triangle with a 30-degree angle, that the ratio of the opposite leg to the adjacent leg is always 0.577 to 1. That's what that means, or radical 3 to 3 ratio. Okay, and again, that's by angle-angle similarity that this works. Okay, sine of, we can say sine of 30. And this will always be an acute angle in geometry. So you'll always plug an acute angle in for theta. acute angle in geometry. When you get to pre-calc, it's a little different. For now, it's always going to be an acute angle. So the sine of 30 is sine is opposite leg over hypotenuse. Okay, so from the 30-degree angle, 3 over 6, or 1/2. It will always be a 1/2 ratio, which we kind of learned already, right? We said a radical 3 and 2a. So a to 2a, that's a 1-to-2 ratio. Type in your calculator, sine 30. Guess what? You get 0.5. All right? And you could do this with the 60-degree. Let's go to cosine of 60. So cosine is adjacent over hypotenuse. So here we have 60. So adjacent over hypotenuse. So adjacent leg over hypotenuse. So 3 to 6, also 1/2. Right? 5. So it's always with respect to the angle that's inside of the trig function. So when you get your triangle, you can label. So if you're working with 60, you would say opposite leg, adjacent leg, and then hypotenuse, and then go from there. So we're going to practice that. Now, SOHCAHTOA is kind of like this mnemonic device that is kind of famous in geometry and trig. It's just a way to remember which trig ratio is which. So it means the sine is the ratio of opposite to hypotenuse. The cosine is the ratio of adjacent to hypotenuse. The tangent is the ratio of opposite to adjacent. To quote a retired math teacher, Mrs. Stafford, she used to say, it stands for some old hobo caught another hobo tripping on acid. I don't use that one, but you're welcome to use it. But I think SOHCAHTOA is easy enough to remember. So let's do some practice. Draw these triangles, and I'm going to have you just write the following. So sine A, cosine A, tangent A, and then we'll do the same with B. And you'll never do that with the right angle, okay, in this class. Okay, so sine of A. Now, notice we're putting variables here for the angle because we don't know the angle measure for these, okay? You'll learn a way to find the angle measure in the next lesson. For now, all we're doing is finding the ratios of each, okay? So from angle A, let's label opposite leg, adjacent leg, and hypotenuse. Remember, hypotenuse is always the longest side. So sine of A is opposite over hypotenuse, 4/5. Cosine of A, adjacent over hypotenuse, 3 to 5. And then tangent over, opposite over adjacent, 4 to 3 ratio. Okay, sine of B. So now with respect to B, you relabel. Okay, so then opposite leg, adjacent leg, and then hypotenuse stays in the same spot. All right, so sine opposite over hypotenuse, 3/5. Cosine adjacent over hypotenuse. I should write SOHCAHTOA so we have it. Okay, 4/5, and then 3/4 opposite over adjacent. And you will notice, it's true, the sine of one of the angles and the cosine of the complement will be the same. Okay, here I'll highlight it. There. And then the tangents will always be reciprocals. All right, go ahead. Do the same with the angle D and angle E. Pause the video, give it a try, and then check your answers. Okay. Sine of D. So opposite over hypotenuse, so 12/13. Cosine of D, adjacent over hypotenuse, is 5/13. And then the tangent of D is opposite over adjacent, 12/5. Now, they're not always going to be rational numbers, you might have some irrationals. Actually, most of the time they will be irrational because of the Pythagorean theorem causes square roots. Okay, so now we have e. Sine of e, opposite over hypotenuse, 5/13. Cosine of e is 12/13. And tangent of e is 5/12. So there you go. So the homework is kind of like this. Now let's finish up here, because I might put this on a test. I can actually have you calculate these special sine, cosine, and tangent values only because we know the special right triangle shortcuts. So if you have a 45, 45, 90 right triangle, the lengths will always be A, radical 2, and a 30, 60, 90, A radical 3, and 2A for the hypotenuse. Okay? So you can actually find for any 30-degree angle the sine ratio for that 30-degree angle because it is opposite over hypotenuse. So it's here, opposite, adjacent, hypotenuse. So A over 2A is simplified to a half. Cosine of that 30-degree angle, adjacent over hypotenuse. A radical 3 over 2A is radical 3 over 2. And tangent of 30 is always A over A radical 3, which is 1 over radical 3. What's wrong with that? We like to have a rationalized denominator. So you multiply by radical 3 over radical 3 and get radical 3 over radical 9, which is 3. Okay? Your calculator will give you the decimal equivalents for all of these. But using what we learned, you can calculate these. Now, you might remember, I told you to use degree mode. Well, why did I do that? Well, because the other mode is radian mode, which you've learned already a little bit, right? We learned that for every 180 degrees, you have pi radians. So 30 degrees was 1/6 of a pi, or pi over 6. 45 degrees was pi over 4 radians. And 60 degrees was pi over 3 radians. So yes, I can ask you to find the sine of pi over 6. You could do that on the calculator with the radian button. These sometimes end up on SATs. So sine of 45 degrees or pi over 4. So let's come over to this triangle. I'm just going to change the color of my pen. So 45, so sine is opposite over hypotenuse. A over A radical 2 is 1 over radical 2. Rationalize the denominator, radical 2 over 2. Cosine 45, or cosine pi over 4 radians. Okay, so adjacent leg over hypotenuse, same thing, A over A radical 2. Rationalize the denominator. Tangent 45, opposite over adjacent, A over A, 1 to 1. Does that make sense? It should, because it's an isosceles triangle, so the legs will always be equal. So it's a 1 to 1 ratio. That's what that means. Go ahead, type in your calculator, tan 45 in degree mode. You should get 1. Because for any 45-degree angle in a right triangle, the ratio of the opposite to the adjacent will be 1. Sine of 60 degrees. So 60, okay, opposite over hypotenuse. A radical 3 over 2A simplifies. Radical 3 over 2, cosine 60, A over 2A, half. And tangent of 60, A radical 3 over A is radical 3 to 1 ratio. So you can calculate all of those, and I will ask you at least one on a test, and you can draw the triangles to help you, so you don't have to have them memorized. And then pre-calc, you'll do a lot more with this. But for now, that's all you need to know. So go ahead and do your Delta Math assignment and enjoy your day.